1970 Chevelle. What's the Chevy got to do in my video? Well, as James Burke used to say, there's a connection. So here's a block diagram of the automatic air conditioning climate control system on the SX4. Sorry about the strobing there, boys. There's not a great deal I can do about that. So you can see the system obviously has a control unit, plenty of inputs and outputs with respect to sensors and actuators, and one input in particular that I was kind of puzzled about, wheel speed. The wheel speed sensing is obviously sensed by the ABS control module via the CAN bus. It's exchanged with the various modules in the car, not the climate control module. It isn't on the CAN bus, but it actually goes through a serial data bus and exchanges with one of the other modules, the data, and it is wheel speed. So why do you suppose an air conditioning system, climate control system, needs to know the vehicle speed? Think about that. Go ahead, I'll wait. Anyway, there's two reasons that I can think of that come to mind. The faster the vehicle goes with respect to the heating mode, the more air is going to flow through the radiator. So the rate of cooling on the radiator is going to change. The system might want to know that. And with respect to air conditioning mode, the rate of cooling going through the through the condenser, let me get that straight, the front of the vehicle, through the condenser, the rate of cooling is going to change with the vehicle speed as well, obviously, as it would do with a function of outside air temperature as well. But there's one other reason, not so obvious, why the vehicle might want to know wheel speed. That's what this video is about. Now, just so it doesn't get confusing, we are talking about automatic air conditioning. I've done my testing on my boy's car, which is manual air conditioning, just Bowden or Bowden cables, however you want to pronounce it. David Bowie, however you choose. Irishman invented them in late 1800s. Interesting story in itself, but I digress. Because it's Bowden cables, everything is just manually positioned. We're not going to get any unexpected changes in the flow through the ductwork. That's why, although I'm talking about climate control here, that's why you're going to see the panel for a manual air conditioning, just so it doesn't confuse you. So in my son's car here, because it has manual air conditioning, and that way the climate control or the automatic air conditioning won't be interfering with the dampers or anything, and we can set everything manually, and we know that everything is pre-positioned. So yeah, just monitoring the plenum flow out of the ductwork there. You can see I'm just set on cold and the fan is in the off position, so this flow should be strictly a function of vehicle speed, basically. Of course, the faster the car goes, the greater the pressure will build up at the cowl area there, and it should actually increase the airflow. So that's what you read in textbooks anyway, so let's convince ourselves of that. I'll go for a drive. I'll try and position you here so you can see it. Oh yeah, by the way, I should have mentioned, so I'm going to capture the data here on the graph here. It'll start graphing soon as I turn it landscape type thing. So away we go, and we'll review the data when we come back. That's 65 kilometers an hour, 80. Kilometers an hour. So here we can see the blue line there. Disregard the yellow line, guys. That's the temperature from the ductwork. I think temperature came down a wee bit as we established some airflow through the ductwork. So again, with no fan operating and just a function of vehicle speed, the pressure that was building at the cowl area and forcing the air through the ductwork. Now, this is no rocket science. It's quite intuitive that people would think that, yeah, you're going to have an increase in airflow as the speed of the vehicle moves. but how much? And I just wanted to get some sense of how to quantify it. So the little cheap anemometer, you can see that there's quite a sharp spike, but when it has to basically, the little turbine has to basically overcome its own inertia before it starts to register. So it didn't start registering until around 50, 60 kilometers an hour, but then you'll notice on the decline, it actually continued to register to quite a lower value is my point. So you have to accept that with a $30 anemometer, you're going to have some limitations, right? But this speed of the air through the ductwork very much actually followed the speed of my vehicle here, guys. You can see that as I came out of the neighborhood to a stop sign, a short stretch where I could increase the vehicle speed again to a stop, a short stretch where I had a moderate speed, just driving back through the neighborhood to back home. So this is kind of interesting, I think. So not only does your climate control want to know the vehicle speed because, yes, there's more airflow through the condenser coil up front. Yes, there's more flow from a heating standpoint. There's more flow through the radiator. But it also wants to know the vehicle speed because there'll actually be a natural increase in flow through the ductwork. So I suspect the algorithm may anticipate that increase in flow and actually slow the fan speed in order to maintain or attain a temperature. It's all considered pretty interesting.